students, to the Chapter 10 review sheet. This is going to be the Part 1 video, and we are going to stay on page, we're going to start on page 562. We're going to do all of these numbers here, up to and including 72. That leaves us with what? 1, 2, 3, 4, 5, 9, 10, 11, 12, about 14. So we're going to do about 26 to 25 problems on this first video, and about 14 problems in the second video. Okay, so this is the review sheet video, part 1, and let's go ahead and jump right into this. Here we go. Numbers 14 and 18 and 19, we're going to graph, I believe, the rational function. So here we go. You should be able to do all of this on your test. First of all, find the vertical asymptotes. In order to find the vertical asymptote, you take the denominator and you set it equal to 0. So bring the 4 over and make it a negative 4. Divide both sides by 3, and x equals negative 1 1/3. So there's the vertical asymptote. Now next, we're going to find the horizontal asymptote. Now the horizontal asymptote is found by comparing the degree of the numerator with the degree of the denominator. Now up here I can't really see it, but I have an x to the 0 power and an x to the 1 power. Anytime the degree in the numerator is smaller than the degree in the denominator, then we automatically have a horizontal asymptote at 0. There's no work to show, just automatically at 0. Now next we're going to find the x-intercept. I've taught you how to do this. Anytime you're looking for the x-intercept, you take the numerator and you set it equal to 0. Well, 3 equals 0 is nothing. There's nothing you can do with that, so there are no x-intercepts. Which makes sense because you have a horizontal asymptote at 0, so your horizontal asymptote is going to fall right on top of the x-axis, right? So there's no way the graph can cross the x-axis, except for a couple of exceptions. Okay, y-intercept. Now to find the y-intercept, everywhere there's an x, you put a 0. So put a 0 here and a 0 here. So you have a 0 up top. 3 times 0 is 0, plus 4 is 4. 0 over 4 is 4. So we're going to have a y-intercept at 0, okay? Now continuing on. And I did just notice I put a 0 here for your x-intercept. I should have put none, and there's going to be an exception to that here in a little bit. You'll see that, but for right now, we'll just keep working. So there's the 4 things you do at first. Then we come over here and we realize, now listen carefully, students. This is where a lot of students get lost right here, okay? So please listen to me carefully. Your vertical asymptote always dictates what you put in for your x values. Let me say that again. Your vertical asymptote, or asymptotes plural, dictate what you put in for your x values. So here's my coordinate plane. I have a vertical asymptote at negative 1 1/3, so about right there. Okay, now I'm going to change that to a decimal so we can use some numbers a little easier. Negative 1.3 repeating, okay? So I have a graph over here on this side of the equation, of the asymptote. And I have a graph over here on this side of the asymptote. So what I have to do is plot points over here and plot points over here to get the two graphs. Do you see what I'm saying? So this vertical asymptote kind of serves as a boundary to let us know what type of numbers to put in for x. So I'm going to go like this. Here's my vertical asymptote. Here's negative 1, 0, 1, 2, 3. I'm going to put in, there's really no set number of x values you have to use. I'm just going to start with 4 because I feel like there's no certain reason. If you don't want to go that far over to 4, that's fine. I'm going to put in a 4, then a 3, then a 2, then a 1, then a 0, then a negative 1. Now I'm right here. Now, you want to get real close to the asymptote without touching it, so that's going to be negative 1.2. Okay? Now I want to go barely past the asymptote, and the asymptote is negative 1.3. So I'm going to go to negative 1.4, and then continue on to 3, 4, 5, 6. So negative 2, negative 3, negative 4, negative 5. 1.5, negative 6. Now, once again, you do not have to put that many values in if you don't want to, okay? And you guys are big Algebra 2 students. I'm not going to take time and put each one of these numbers into the function for you, okay? There's no need to do that. But if you have a graph where you can type this thing into your graph where you would type 3 divided by, then parentheses, don't forget your parentheses because this is a binomial right here and you must be sure and tell the computer this whole thing goes together, alright? And then go to your tables, type that in and go to your table and you can fill this out pretty quickly, okay? So here we go. Let's see, we're going to negative 6. So negative 6 would give me negative 0.21. Negative 5 is negative 0.27. Negative 4 is negative 0.38. Negative 3 is negative 0.6. Negative 2 is negative 1.5. And then negative 2. Negative 1 is 3. 0 is 0.75. 1 is 0.43. Of course, I'm rounding these. 2 is 0.3. 3 is 0.23. And 4 is 0.19. Now, let's go ahead and find these values, putting 1.2 in for x. And I'm going to do that quickly here and see what I get. We're going to type in negative 1.2. And we're going to get out 7.5. And then I'm going to put negative 1.4 in for x. And I'm going to get negative 15. Alright, so there we go. I've got my table of values. I've got my asymptotes over here. I'm pretty sure I'm good for everything. Okay, and by the way, I'm not sure why I got 0 for my y-intercept over here. That's totally wrong. Everywhere there's an x, we put a 0. You would get 3/4 for your y-intercept. 3/4. 3 times 0 is 0 plus 4 is 4. 3 over 4. So that's definitely wrong, and I apologize for that. Okay. I'm going to erase this, so memorize this. Vertical asymptote, negative 1 1/3. Horizontal asymptote at 0. Y-intercept at 3/4. So here we go. I'll use a different color here. I guess I'll use red for the I'll use black for my asymptotes. So I have a vertical asymptote at negative 1 1/3. So we'll put that negative 1 1/3. Horizontal asymptote, of course, is right here on the x-axis, right there. And I have a y-intercept of 3/4. So there's my y-intercept, and we're good to go. 4.19, so over 4. Here's the origin right here. 1, 2, 3, 4, up 0.19. 3 is at 0.23, a little higher. 2 is at 0.3, a little higher. One is at 0.43. Actually, I've got these too high, to be honest with you. 0.19 would be way down here. This would be barely here. This would be here. This would be here. 0 is 0.75. Negative 1 is at 3. So I think I've got a pretty good picture of this graph, don't you think so, guys? Look at that. Getting closer and closer to my horizontal asymptote. Getting closer and closer to my vertical asymptote. In fact, at negative 1.2, that's right here. It shoots way up to 7.5, so way up here. So there we go. Now, let's start over here at negative 6. that's right. My fault, guys. Negative 3 is negative 0.6. Negative 2 is negative 1.5. There we go. And then 1.4 shoots you way down to negative 15. So way down here so we can see the graph. It's going to hit here and then start shooting down quickly, getting closer and closer to the vertical asymptote, but never crossing it, and getting closer and closer to the horizontal asymptote, but never crossing it. Okay, moving on to the next one. Alright, number 18. Okay, step 1, let's find the vertical asymptotes. Take the denominator, set it equal to 0, and solve. Okay, we're going to factor this to solve it. What two numbers would multiply together give me 7? When add together give me 8. That's a positive 7 and a positive 1. Multiply those, you get 7. Add those, you get 8. So the factorization would be x positive 7, x positive 1. Set this group equal to 0 and solve negative 7. Set this group equal to 0 and solve negative 1. So your vertical asymptotes are 7, negative 7, comma, negative 1. Okay, so there's your vertical asymptotes. Now, your horizontal asymptotes, well, let's compare the degree with the numerator to the denominator. Here's your degree in the numerator, here's your degree in the denominator. They're the same. Whenever your degree up top is the same as the bottom, you take your lead coefficient, which is 4, and your lead coefficient down here in the bottom, and you put them over each other. 4 over 1 is your horizontal asymptote. Now you only do this with a degree up top matches the degree in the denominator. So my vertical asymptote is at 4. Alright. Now, the x-intercept, to find the x-intercept, you take your numerator and you set it equal to 0 and you solve. Bring your 1 over and make it positive. Divide by 4. Now take the square root of both sides, and x equals plus minus the square root of 1 is 1, and the square root of 4 is 2. So the x-intercept would be, your x-intercepts are positive negative 1/2. And now let's find your y-intercept. You do that by putting a 0. Everywhere there's an x, put a 0 here, 0 here, and a 0 here. 0 squared times 4 is 0, minus 1 is negative 1. 0 squared plus 8 times 0, 0 plus 7 is 7. So your y-intercept would be a negative over a positive is negative, so negative 1/7. And now we're ready to get our table of values. Ready, okay? So let's get a little space here. In fact, we probably don't even need this anymore. Not yet anyways. Okay. Okay, there's my table. Now, remember your intercepts help you find your values. We have vertical asymptotes at negative 1. So we have an asymptote at negative 1 and an asymptote at negative 7. Okay? So we're going to go to the right. We're going to go 0, 1, 2, 3. So I'm going to go 3, 2, 1, 0. And then get real close to this, negative 0.9. And then get real close to the other side of it, negative 1.1. And then negative 2, 3, 4, 5, 6. So negative 2, negative 3, negative 4, negative 5, negative 6. Now, I'm going to get real close to this asymptote, so negative 6.9, and then negative 7.1. And then go past the 7, so negative 8, negative 9, negative 10. And there we go. Now, that's a huge table of values, but that is what you have to do to graph this. Let me quickly type this into my calculator. So I'm putting a parentheses around 4x squared. 4x squared minus 1, put that in parentheses, divided by, and then put this in parentheses, x squared plus 8x plus 7. Close my parentheses, and we'll go to my table, and here we go. So we're going to go to negative 10 and work from there. So negative 10 gives you, wow, 14.8. Negative 9 is 20.2. Negative 8 is 36.4. 6. Negative 6 is negative 28.6. Negative 5 is negative 12.4. Negative 4 is negative 7. Negative 3 is negative 4.4. Negative 2 is negative 3. 0 is negative 0.14. Negative 1 is 0.19. 2 is 0.56. And 3 is 0.88, rounding of course. Now, let's go back and quickly type in some of these values. Negative 0.9. Negative 0.9 gives out 3.7. Negative 1.1. Would give us out negative 6.5. Let's come down here to negative 6.9. Negative 6.9 would give us out negative 321. Wow. Negative 321. And negative 7.1 would give us out 329. Of course, I'm rounding. 329. So, I really have everything that I need to get my graph set up. I'm going to slide this to the next page so I have some room to work with. I'm going to erase this here, and I'm going to get rid of this here. And I think we're going to be doing pretty good here. And here we go. Get this over here out of the way a little bit. And here we go. Most of my work is going to be over here to the left of the origin. So I'm going to make my graph like this. Just trying to be smart here and think ahead. Alright, and here we go. Now let's see what the vertical asymptote's negative 7, negative 1. So negative 1 and negative 7. So here's negative 1. There we go. 2, 3, 4, 5, 6, 7. There's negative 7. Alright, so there's my two vertical asymptotes. My horizontal asymptote is at 4. So my horizontal asymptote, 1, 2, 3, 4. Alright, don't forget, this is your y-axis up here. This is your x-axis right here. Alright, now, let's plot these points and see what happens. At 3, we're at 0.8. So 3 is at 0.8. 2 is at 0.56. 1 is at 0.19. And 0 is at negative 0.14. And then when I get real close to 0.9 right here, it shoots down. It goes up to 3.7. I wonder if that's supposed to be negative or not right there. I'm going to see if it is. I'm going to try that again. I'm wondering if I made a mistake. Let's see. Negative 0.9. Negative 0.9 is... Actually, it's not. It does a little thing like that. It's fine. 3.4. Okay, so... Okay, I paused the video just to make sure I hadn't made a mistake, and I've not. So it does one of those kind of weird things. Kind of... the graph actually comes down like this. Like this, and goes up to 3.7, about right here, and then comes down and goes a little lower like this, and then starts coming back up again like this. Alright, now I'm not sure what it does up here. The only way to know that is to continue to put more and more numbers in, like negative 0.999. You know, we could try that and see. because this is one of the horizontal asymptotes that is going to get broken. This is going to keep going up and up. All right. Now let's come over here. We're at negative 1.1, so we're barely past the asymptote. It's negative 6.5. 1, 2, 3, 4, 5, 6.5. So right there. All right. Negative 2 is negative 3. Negative 3 is negative 4.4. 1, 2, 3, 4.4. So about right here. Negative 5 would be boy guys, I apologize. Let's try this again. Negative 1.1 is negative 6.5. 1, 2, 3, 4, 5, 6.5. So like right there. And then negative 1 or negative 2 is negative 3 right here. And then negative 3 is negative 4.4. So about right there. And then negative 5 would be negative 12.4 way down here. And then negative 6, of course, is negative 28.6, so going down really far. Alright. And so we're going to have the same thing kind of happen here. It's going to come up, hit here, and then make a little turn, and then start going down, getting closer and closer to the vertical asymptote. And this is going to continue this way too, going further and further down, moving more to the left. Now, let's take a look at negative 7.1. Now look at negative 7.1. Negative 7.1 is like 329 way up here. And negative 8 is negative 36.4. Negative 9 is negative 20.2. And negative 10 is negative 14.8. So it's going to be up here. And obviously, with the negative 8, with the negative 7.1, barely to the left, sorry for yawning, to the left of the vertical asymptote, it's way up high. And then we're going to start coming down and hitting some numbers, 36.4, 20.2, 14.8, like this, getting closer and closer to the horizontal asymptote, but never touching it, okay? I'm just kind of sketching that freehand because I don't have a graph that goes all the way up to 36 and 20 and 14, okay? But hopefully you get the idea, alright? Okay, moving on to number 19. Alright, now let's first of all find the vertical asymptote like we're supposed to. So vertical asymptote is 3x squared plus 6x equals 0. Factor out a 3 and an x, and you're left with x plus 2. Let's check our work. 3x times x, 3x squared, 3x times 2 is 6x. Take this group here, set it equal to 0, and you'll get 0. Take this group, set it equal to 0, solve, you get negative 2, so your vertical asymptotes are 0 and negative 2. Now your horizontal asymptote is none. Whenever the degree in the numerator is greater than or larger than the degree in the denominator, then you have no horizontal asymptote. Okay? Now the x-intercept, well, we're going to take the numerator, set it equal to 0, and solve. There we go. And very quickly, let's factor this. Well, it's not factorable, okay? So it's not factorable, guys. I'll be honest with you. We really don't have to solve this. We don't have to know the x-intercept. To solve this, we're going to have to make a list of possible rational zeros and test each one and all that kind of stuff. So I'm not going to worry about that. That's fine. So the x-intercepts, we'll find those as we graph them. The y-intercepts, everywhere there's an x, we'll put a 0. So put a 0 here, put a 0 here, put a 0 here, and look at this, guys. There's none, because look at your denominator. 0 squared is 0 times 3 is 0, plus 6 times 0 is 0, 0 plus 0 is 0. Your denominator is going to be 0, and you cannot have a denominator of 0. So there will not be a y-intercept. Y-intercept, none. Alright. So we've done our 4 things. The x-intercept we're not going to worry about. So we're ready now for our table of values, okay? So let's put this here. vertical asymptote of 0 and negative 2. So here we go. If I have a vertical asymptote right here at 0 and right here at negative 2, negative 2 and 0, then my x values will be the following. First of all, I'm going to go to the right of this 0. 1, 2, 3, 4. So I'm going to put in 4. 3, 2, 1. Then I'm going to get real close to this. So 0.1. Then go barely past it, negative 0.1. And then negative 1 for this number here. They get real close to negative 2. So negative 1.9. Then barely go past negative 2. Negative 2.1. And then we'll go negative 3, 4, 5, 6. Negative 3. Negative 4. Negative 5. Negative 6. Alright. Let me quickly grab my calculator here and type this top numerator in my calculator. 2x cubed minus x, or negative x, plus 10. Close the parentheses. And then divide it by 3x squared. Plus 6x. And close the parentheses. Now we'll go to our table and we'll see what we have here, okay? Negative 6 is negative 5.78. Negative 5 is negative 5.2. Negative 4 is negative 4.75. Negative 3 is negative 4.55. Negative 1 would give you negative 3. And then positive 1 would give you 1.2. And 2 would give you 1. And 3 would give you 1.4. And 4 would give you an output of 1.86 or 1.9. Okay, now let's put in 0.1 real quick and see what happens. We'll get out 15.7. Now let's try negative 0.1. Negative 17.7. And now let's substitute negative 1.9 in. And we'll get out 3.2. And then negative 2.1. And it does not seem to be working. I wonder why. Alright, let's try it again. Okay, pause the video here. For some reason, students, my calculator will not let me put in negative 2.1. I'm going to come back to that later, okay? We will come back to that, but my vertical asymptotes are at 0 and negative 2, so let's get rid of that, and I think we can get rid of that, and let's get our coordinate plane up here. Alright, there we go. asymptote right here, falling on top of the y-axis. And here's the other asymptote falling right on -2. Alright, there we go. Now back to our graph here. So 1 is 1.2. So it actually starts to go back up again, dips a little bit, 1.2. And then 0.1 goes up to 15. So it goes up to 15 here. So it's going to come down. It's going to hit here. It's going to come down. And then start to come back up again. Like this. Alright. And there we go. Now, let's see what happens between these two asymptotes. We have negative 0.1 is way down here at -17. -1 is at -3. And then negative 1.9 is 3.2. So it would be up here, about right here. So it looks like to me the graph comes down like this, starts here, hits this point, starts to curve over, slowly hit here, and then continue on down. Alright? That looks like what it's doing. Now, let's take a look at -3. 1, 2, 3 is -4.55. Right there. -4 is -4.75. -5 is -5.2. So about right there. And then -6 is -5.78, so a little more right here. So it looks like to me the graph's going to come up, hit here, and eventually start to curve up, getting closer and closer to the vertical asymptote, but never touching it, and continue coming out this way. Alright, and there we go. So there's the graph of that rational function. A lot of work, I know, guys, but that's how you do this. Okay, now let's move on to some faster problems. Okay, number 23, the directions say that x and y vary inversely. Write an equation that relates them. Okay, so inversely means to use this model here, where the y is I will put a 5, where the x is I will put a 1. Multiply both sides by 1 to get k by itself. 1 times 5 is 5. 5 equals k. So pick up 5 and put it right here for k. And that is the answer that we want. Now they're going to have xy equals 5. I don't want you to write it like that. I want you to leave it just like this, which is the exact same thing as the answer. Y equals 5 over x. Number 25, the directions say that x and y vary jointly. Write an equation that relates them so varies jointly. Z equals kxy. Where the z is, I will put a 4. Where the k is, I will put a k. Where the x is, I will put a 1. And where the y is, I will put a 12. So 1 times 12 is 12. So now I have 4 equals 12k. Divide both sides by 12. And we get 1/3 or 0.3 repeating. Pick this up and put it in for k right here, because 1/3 equals k. And there's your model. Z equals 1/3 xy. Moving on to number 27 and 28. Now here, they want us to state whether or not this relationship in the table of values is inverse or direct. Now there's a fast way to do this, but I'm going to go with a more, not necessarily fast, but the easier way to understand. Okay, look, if you're trying to see if these numbers have a direct or an inverse relationship, students, come on, think about it. Just write a model and see if it works. For example, let's pretend they vary directly, okay? So we should have this here, right? If they vary, I'm not saying they vary directly. I'm saying if they do, then we should be able to use this model right here. So let's take our first ordered pair. Where the x is, I'll put a 1. Where the y is, I'll put a 60. 1 times k is k, so k equals 60. So if k equals 60, then I can put y equals 60x. Now this model should work for every ordered pair. So put a 2 in for x. 60 times 2 is 120. Well, up here when they put 2 in, what they get out? 30. Does that fit into this? Not at all. It only has to fail once for you to know it doesn't work. So we don't have direct variation. Well, maybe we have inverse variation. Let's try it and see. Y equals k over x. Where the y is, I will put a 60. And by the way, Mr. Error, why are you using this ordered pair? Look, you can use any ordered pair to solve for k. It does not matter. Does not matter. Y is 60, x is 1. Multiply both sides by 160 equals k. So where the k is, I'll put a 60. Now let's check the other order pairs. This one checks. Put a 2 in for x. 60 over 2 is 30. Check. Put a 3 in for x. 60 over 3 is 20. Check. Put a 4 in. 60 over 4 is 15. 15. Check. Put a 5 in for x. 60 over 5 is 12. 12. Check. So this relationship here is inverse variation. Now, 28. Let's see if it's direct or inverse. Let's try direct first. Take any order pair you want. We'll try this one. Doesn't matter. Where the y is, I'll put a 24. Where the x is, I will put a 2. 2 and 24. Divide both sides by 2 and 12 equals k. So where the k is, I will put a 12. And there we go. Now let's test this with every point up here. Let's see what happens, okay? Put a 5 in for x. 12 times 5 is 60. 60. Put a 4 in for x. 12 times 4 is 48. Check. Put a 3 in for x. 12 times 3 is 36. Check. Put a 2 in for x. 12 times 2 is 24. Put a 1 in for x. 12 times 1 is 12. Check. So we have direct variation. Direct variation. Okay, moving on to numbers 33 through 40. We're going to multiply or divide depending on what they ask us to do. Okay, students, here we go. First of all, in order to solve this or simplify it, however you want to look at it, the first thing we're going to do is we're going to follow our steps. You always want to factor any numerator or denominator that's factorable. Well, nothing's factorable because we have a monomial, 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 monomial. Now, the good part is we can do a bunch of canceling, okay? A bunch of canceling. Like, for example, 5 goes into 10 twice. I have 1x here and 2x's here, so I can take 1x away, and that'll leave me with 1x up here. 1y, 4y's. Take a y away, so everything's gone here except for a 1. This y will become y to the third. So up here I have 2x y to the third. Now, actually I'm not going to circle that. Now let's cross cancel this way. 3 goes into 24 8 times. I have 3x's and 4x's. Take 3x's away. That leaves me with 1x. I have 2 y's here and 1 y. Take your 1 y away. Take 1 y away, leaving you with a y. Okay? Now I've got some more canceling I can do. Look at your vertical canceling. I have an x here and an x here. So this x reduces with this x here. So I have nothing left down here but a 1. So let's go ahead and multiply. 1 times 1 is 1. 8y. So up top here I have 8y. Up top over here I have 2y cubed. So I have 8y times 2y cubed. 8 times 2 is 16. Y times y to the third is y to the fourth. So your answer is 16y to the fourth. 16y to the fourth. Number 34, same thing. No factoring can take place because I have all monomials. So let's do some reducing. Your 2 goes into the 6, leaving you with a 3. Alright, I don't like this. I'm going to go ahead and put the answer up here. I don't care. I'm going to slide this down so I have some room to write above the fraction too. Okay, 2 goes into 6 3 times. There we go. I would strongly encourage you students to not try to cancel negative exponents. Just leave those alone, okay? Just leave those alone. I've got a y here that cancels with a y here. Let's go this way now. I've got 3x's and 1x. So take 1x away. Take 1x away, leaves me with 2x's. I've got 2y's and 5y's. Take 2y's away. Take 2y's away from here. I'm left with y to the third. And it's really about all I can see. If I'm missing anything, it really doesn't matter because we can reduce our answer later. So up top here, I'm left with 9y to the third. Here I'm left with 3x to the negative 1. Down here I'm left with x squared. And here I'm left with x squared. So let's see what we get. 9 times 3 is 27. Y to the cube times x to the negative 1 would be y cubed x to the negative 1. Here we have x squared times x squared x to the fourth. Now we're almost finished. You don't want your final answer to have negative exponents. So remember what to do. You pick up this x with a negative 1. positive 1. X to the 4th times x to the 1st would be x to the 5th. X to the 5th, so 27y cubed over x to the 5th. And there's the answer. There we go. Number 35. Okay, now we're getting into some problems where we can factor a little bit. Alright, so let's go through and factor all that we can factor. Let's slide this down just a little bit so we can work above it and below it. Okay, let's factor this first. X cubed 3x squared negative x. First you can pull an x out and you're left with x squared plus 3x minus 10x. So I put minus 10. So I pulled an x out. Okay, next I can factor this. Now I'm going pretty fast, but by now we really should know how to factor. What two numbers when multiplied together give you negative 10? When added together give you a positive 3. 5 and negative 2. So x positive 5, x negative 2. Alright, so this entire thing is gone. And I will replace it with this factored expression. And there we go. Now, let's factor. Let's go ahead and put this over 1 first of all. Let's factor this next. We can pull a 3 out of everything. So 3x squared positive 3x negative 10. That's the exact same thing we had, isn't it? Yes, it is. This is the exact same thing we just factored here. So the factorization is going to be the same, except instead of having an x on the outside, we'll have a 3 on the outside, because up here we pulled out an x. Down here we're pulling out a 3. Be x positive 5, x negative 2. Exact same thing. Alright. And there we go. Now, we can also factor this. We can pull a 3 out of both terms. So pull out a 3, and we're left with x negative 10. And now let's get to work cross canceling. This 3 right here is a monomial. Cancel this monomial. Do not cancel this x with this x. This is a monomial. This is a binomial. You have to cancel like nomials with like nomials, okay? But I've got an x positive 5 cancel with x positive 5. Or reduce this x negative 2, reduce with x negative 2. So I have nothing here, that's a 1. I have nothing here, that's a 1. Here I have an x and an x negative 10. So x times x negative 10 all over 1. X times x negative 10 all over 1. That should be your answer. Unless they multiplied the x through, which they did not. So that is the answer. Okay, number 36. Okay, we're going to factor again as much as we can. Let's put this over 1. And let's start off first of all with this expression here. We can pull out an x, and when we do, we're left with x negative 3. No more factoring we can do there. Here we're going to pull out a 4 and an x, and we're left with x negative 2. Nothing else we can do here. Now we can do a lot of factoring here. First of all, pull out a 4, and you're left with x squared negative 4. Then you can factor this because we have perfect squares. The square root of x squared is x, but an x and an x. The square root of 4 is 2. Put a 2 and a 2, make one positive, make one negative. So all of this will go up top, up here. And this is now gone. And we'll get rid of this. Let's start cross canceling. I've got an x negative 2 here and an x negative 2 here. I have a monomial 4 and a monomial 4. Now I can also vertically reduce this x here and this x here. Those reduce. So I'm left with nothing here but a 1. So I have x negative 3 right here times x positive 2 all over 1. Because 1 times 1 is 1. Obviously you don't have to put that 1 if you don't want to. And that is your answer. Alright, moving on to 37. Now here we're dividing, so don't forget we are going to have to flip the second fraction, okay? We are going to have to do that eventually. So understand that. Alright, let's factor this trinomial here. What two numbers when multiplied together give me a negative 3, would add together give me a negative 2. That's a negative 3 and a positive 1. Alright. We cannot factor this here. What two numbers when multiplied together give me negative 12, when add together give me a positive 1. Well, that's going to be a positive 4 and a negative 3. And then down here we can factor this right here because we have perfect squares. So the factorization would be square root of x squared, x and x. Square root of 1 is 1. Make one positive, make one negative. And this is gone. Now, we're looking good, except we got to flip this fraction and multiply. So let's make this multiplication. Let's grab this and pull this down here for the denominator. And let's grab this here and pull that up for the numerator. That'll go right there. So we flipped the second fraction, okay? And now we're multiplying. Cross cancel. Well, x negative 3 cancels with x negative 3. And look, we've got a vertical reduce here. X positive 1 cancels with x positive 1. So now let's see if we can vertically reduce. I don't see anything. So 1 times these two parentheses would just be x positive 1, x negative 1. And then 1 times x plus 4 would be x plus 4, or x positive 4. And that should be your answer. Alright, moving on to number 38. Same thing again. We're going to have to flip the second fraction and multiply. Now before I do that, let's factor first, okay? Cannot factor this, cannot factor this. However, I might be able to factor this. What two numbers would multiply together give me negative 40? When add together give me a positive 6. I'm thinking 10 and 4 because 10 times 4 is 40. So I'm thinking a positive 10 and a negative 4. And that'll work. Now down here we got to factor out an x squared first, leaving us with x squared. Positive 9x, negative 10. So what two numbers would multiply together give me a negative 10? When add together give me a positive 9. I'm thinking a positive 10 and a negative 1. Because when you multiply them, you get negative 10. When you combine them, you get a positive 9. So it's looking pretty good, okay? Now, here's the thing. I've got to flip the second fraction, so really, technically, this here should be down here, and this should be up here, like this, and this should be here. This should be an x squared. So this is gone, and this is gone. So I can cross cancel x negative 4, x negative 4. There's nothing here but a 1. I've got 4 x's and 2 x's. Take 2 x's away, leaves me with 2 x's. Vertical reducing, x positive 10, x positive 10. Nothing left here, so a 1. So 1 times x negative 1 is x negative 1. X squared times 1 is x squared. That would be your answer, x negative 1 over x squared. Please do not try to reduce these two x's. This is a binomial. This is a monomial. Number 39. Okay, we're going to have to flip the second fraction again. We're dealing with division, so let's get this down here and get some room. Okay, first of all, I can pull out a 4 into x squared here, and that's going to leave me with x minus 10, or x negative 10. Alright, so we'll cross this off here. I can pull out a 2, leaves me with x positive 5. So that's factor. You cannot factor this binomial any further. Here we can factor out an x. For this top one right here, factor out an x, leaves us with x squared. Negative 9x minus 10. And then, of course, what two numbers would multiply together give you a negative 10. When add together give you a negative 9. That's going to be x negative 10, x positive 1. Negative 10 times 1 is negative 10. Combine those two, you get negative 9. So, the entire factorization of this numerator is that right there. Alright, now here's the thing though. We got to multiply and flip our fraction. So technically this right here comes down here in the bottom like this. And then x plus 5 is going to go up top. Right here. And now let's start canceling. Here we go. X plus 5, x plus 5, x negative 10, x negative 10. I've got a monomial here and a monomial here. Take 1x away. Take 1x away from here. You have 2. Take 1 away, so you're left with 4x. Now we have a 2 here and a 4 here, so your 2's gone. Nothing left here but a 1. Reduce this by 2. Reduce your 4 2x. So here I'm left with nothing but 1. Here nothing but 1. So I'm left with 2x times 1, that's 2x. And down here I'm left with 1 times x plus 1. X plus 1, and hopefully that's the answer. And yes it is. Okay, number 40. Alright, same thing. So here we go. We're going to pull out a 5x cubed here, and we're left with x minus 10, I believe. Let's multiply this back through here. 5x to the 4th, yep, that's right. Here we're going to say to ourselves, what two numbers would multiply together give me a negative 71? Combine give me a negative 3. I'm thinking of 10 and 7. Like x negative 10, x positive 7. That should work. Negative 10 times 7, negative 70. Negative 10 plus 7 is a negative 3. Alright, so we're looking pretty good there. Alright, moving on. Now this is going to be over 1. Correct. Correct. But first I'm going to factor out a 5x squared here. So pull out a 5x squared, and you're left with x positive 5, I believe. 5x squared times x, 5x cubed. 5x squared times 5, yeah, that's right. So now we're going to multiply and flip the second fraction. So really, this is going to come down here to the denominator, and this 1 is going to come up top. And this is going to be right here, so we flip the second fraction. Alright, and this is now gone. So here we go. I have a 5x, I got a 5 here that cancels with a 5. I have 2 x's here and 3 x's here, so take 2 x's away. Take 2 x's away, leaves you with an x. Vertically, I have x negative 10, x negative 10. So the only thing I'm left with here is an x. Here I'm left with an x positive 7, x positive 5, so x times 1 is x. X plus 7 times x plus 5 would be this right here. And I believe that's the right answer, at least I hope it is. It is good. Alright, moving on to 45 through 53, we're going to solve these equations, okay? Solve the equations. Well, I've taught you how to do these. Step 1, you want to factor the numerators and denominators as much as possible, okay? Now, once you've done that, you then want to find a common denominator. So one denominator is x minus 1, the other denominator is x plus 11. Now, how many groups of x minus 1? 1. How many groups over here? None. So I have one group of x minus 1. How many groups of x plus 11? 1. How many over here? None. So I have x plus 11. Let me stop and do something. I did notice there's one factoring I could have done. Actually, you factor the denominators. This is what I've taught you to do. You factor the denominators because you're looking for a common denominator, okay? So now we're going to multiply this entire fraction, or this entire problem. We're going to multiply this entire equation by this right here over 1, alright? That's my common denominator. So we're going to multiply the entire equation by this, alright? So x minus 1 cancels with x minus 1, leaving you with x plus 11 times x. So I have x plus 11 times x equals, then here I have x positive 11 cancels with x positive 11, leaving me with x negative 1 times the binomial 2x plus 10. So students, it looks like I'm going to have to do some work here now. I've eliminated my fractions. Now I've got to do some simplifying here. First of all, x times 11, x times x, that's x squared plus 11x. Over here, I've got a binomial times a binomial. Students, we've done 100 of these this year. I'm not going to walk you through this. I'm just going to tell you now you're going to get 2x squared, negative 10, negative 2, positive 10, positive 8x. There we go. So if you do all your multiplying here, this is what you'll get. Now, you should notice right away you have a quadratic equation, so you want to get one side equal to 0. So bring your x squared over, make it a negative x squared. Bring your 11 over, make it negative 11. And we're left with 0 equals 2 minus 1 is 1x squared. 8 negative 11 is negative 3x. Bring down your negative 10. Now we can factor this. Okay, we can factor this right side What two numbers that multiply together give me a negative 10? When add together give me a negative 3. That's going to be a positive 2, and a negative 5. Alright, there we go. There we go. Positive 2, negative 5. Now, if you take this group, set it equal to 0 and solve, you'll get negative 2. If you take this group here and set it equal and solve, you'll get a positive 5. So it looks like your two answers are negative 2 and 5. Now, please don't forget on the upcoming test, you must check these answers to make sure you get out a true statement. You must check both of them. Sometimes they'll both work, sometimes neither one will work, and sometimes one will work and not the other. But in this case, they both do work. Number 47. Okay, here we go. First of all, you want to factor your denominators as much as you possibly can, and there is no factoring of the denominator. So next, we are going to find our common denominator. This 1 is really over 1. As you can see, someone wrote in the book already and put that. I did not do that, but there it is. So I have a monomial of x. There's no x's here. There's no x's here. This is a binomial here. So comparing my monomials, I have 1x here, none here, and none here. That's 1x. I have one group of x minus 1, none here, and none here. So one group of x minus 1. So there's my common denominator. I'm going to take that and multiply it times the entire equation. Alright, so I'll put my parentheses here, and here we go. Your x would cancel with your x, leaving you with x minus 1 times x plus 3. So x negative 1 times x positive 3. Next, in this fraction, this will cancel with nothing. So basically I have x minus 1 times negative 1. Now this negative sign goes to everything, so please watch how I do this. I have a negative 1 here. Times what? X. Times what? X negative 1. Okay? Nothing canceled. 1's not going to cancel with anything up here. So I just take the top times the top. And of course it's all over 1, but you do not need to put that. Now here, x minus 1 cancels with x minus 1, leaving you with x times 1. And now we're ready to simplify, so let's solve our equation. When you multiply these two parentheses together, you will get x squared, positive 2x, negative 3. And then negative 1 times x is negative x. Then take your negative x and multiply it through. I better do this up here so you can see it. Okay, I have negative 1, and then an x, and then an x negative 1. Negative 1 times x is negative x. Bring down your x negative 1. And then negative x times x is negative x squared. Negative x times negative 1, positive x, equals x. Now, we thought we had a quadratic equation, but look, your x squared cancels with your x squared. So that's gone. That leaves you with 2x plus x, that's 3x. Negative 3 equals x. Well guys, this is a simple linear equation. You know how to solve this. Bring your x over, make it a negative x. Bring your 3 over, make it a positive 3. So your x is gone and your 3 is gone. So you're left with 3x minus x, 2x. And over here you're left with a positive 3. Divide both sides by 2 and you'll get 3 over 2. Or 1.5 or 1.5. Now, again students, you must remember on the test to take that answer and to substitute it into your equation and make sure you get out a true statement, okay? You have to do that. Please don't forget to do that. Okay, moving on to number 49. Okay, let's solve this equation. First of all, remember we're going to factor the denominators because we're looking for a common denominator. Now, I have one group of x minus 4, no groups of x minus 4, one group of x minus 4, okay? So, my common denominator is just simply going to be x negative 4 because the group that has the most only has 1, so I need just one of these. So I'm going to take this, x negative 4 over 1, I'm going to multiply it times everything in this entire equation very carefully. Alright, so here we go. First of all, x negative 4 cancels with x negative 4, just leaving you with a 1 here. So 1 times x plus 8 is x positive 8. Then next I have a positive 3 negative 4 leave you with the 1. 1 times 6x minus 2 is just 6x negative 2. We got a simple linear equation to solve this thing, no problem. X positive 8 multiply your 3 through positive 3x negative 12 equals 6x negative 12. Now let's bring our 6 up. Well, let's simplify over here. X and 3x is 4x. 8 negative 12 is negative 4. Bring your 6x over and make it a negative 6x. Bring your negative 4 over and make it a positive 4. And you're left with negative 2x equals negative 8. Negative 2x equals negative 2,8. Now divide both sides by a negative 2. Negative 8 divided by a negative 2 is a positive 4. So there's your answer. However, if you'll look at the denominator, students, please look at the original problem, the denominator. If you go to check this answer and you put a 4 in for x, you're going to have 4 minus 4 right here. That gives you 0 for a denominator. You can never have a 0 in a denominator, so there's no way this answer works. So 4 does not work, so the answer is no solution. Alright, let's try number 51. Alright, let's find our common denominator. Remember, when you're finding a common denominator, compare monomials with monomials, binomials with binomials. I have an x minus 2 binomial. There's one group here, none here, and none here, so I need 1. Here I have a monomial of a 3 and a monomial of a 3. I have no monomials over here. I have 1, 3 here and 1, 3 here. Which group has the most? Well, they both have 1, so I just need 1. And there's your common denominator. 3 times x negative 2 all over 1. And here we go. Multiply this times this. Your x negative 2's cancel, leaving you with 3 times 2, which is 6. Now watch your signs. We got a negative sign here, okay? Your 3 cancels with your 3, leaving you with negative 2x times x negative 2. So be careful there, okay? And the same thing happens over here. Your 3 cancels with your 3, leaving you with x negative 2 times x negative 3. So let's get after this. Looks like we might have a quadratic equation. Alright, so let's simplify the left side and simplify the right side. We have 6 negative 2x times x negative 2x squared. Negative 2x times negative 2 positive 4x. Over here, if you multiply these two binomials together, you'll get x squared negative 5x positive 6. Okay, well guys, here we go. I mean, it's just going to be a lot of work, okay? There's nothing I can do unless I made a mistake somewhere, and I hope I haven't, but if I have, we'll have to go back and just start over, okay? So here we go. I'm going to bring my negative 2x over and make it a positive 2x squared. That way I have a positive lead coefficient. Bring my 6 over, make it a negative 6. Bring my 4x over, make it a negative 4x. So I'm left with 0 equals 3x squared minus 9x, and these cancel. Man, we can factor this so easily, guys. Pull out a 3x, and you're left with x negative 3. Pull out a 3x, and you're left with x negative 3. Take this group, set it equal to 0, and solve, and you get 0. Take this group, set it equal to 0, and solve, and you get 3. So your answer would be 0 and 3, 0 and 3. So remember, if you took those two answers and you substitute them back in and checked your answer, you would get out 2 true statements. This would give you out a true statement, and so would 3. Alright, number 53. Alright, here we go. Okay, let's factor any denominators that we can factor, because we're going to find a common denominator. There's no factoring I can do. So I have a monomial here, none here, and none here. So I have one group of x, none, and none. So I need an x. Compare your binomials. One group of x minus 2, one group of x minus 2. So the most I have in one denominator is one group. So I need one group. There we go. There's my common denominator, just like that. Take that common denominator, multiply it by everything in this equation, and let's see what happens, okay? Here my x would cancel with my x, leaving me with x minus 2 times x plus 2. It is a positive sign here, so I'm not too worried about my signs. X times x positive 2 equals, and then here your x negative 2 cancels with your x negative 2, leaving you with x times 3x, 3x squared. So let's simplify and multiply these two together. We'll get 2x squared, a negative 8, and then a negative 4, and a positive 4. They cancel out, alright? So 2x squared, negative 8, and then positive x times x is x squared, x times 2 is 2x, equals 3x squared. Alright, now let's see here. It looks like, oh, you know what, guys? Everything's good. The x squareds are going to cancel out. Look, 2x squared plus x squared, that's 3x squared. Positive 2x, negative 8 equals 3x squared. I took this square term here and this square term here and I combined them. Positive 2, positive 1, positive 3x squared. And I just brought down the 2x and brought down the negative 8. Now, if you bring the 3x squared over, make it a negative 3x squared. These cancel, leaving you with 2x negative 8 equals 0. So obviously bring your 8 over and make it positive, and divide both sides by 2. And there's your answer, x equals 4. Okay? And obviously it does check. Alright? Okay, moving on. Now we're going to add and subtract fractions or rational expressions. Okay? So we're going to have to get a common denominator and then combine fractions. So here we go. Anytime we can factor the numerator or the denominator in these problems, it can be a help to us, okay? Not always, but sometimes it can be, okay? So here we go. There's nothing to factor here, so I'm not going to worry about that. And let's find our common denominator. Remember, you can never add or subtract fractions unless they have a common denominator. So I have one group of x minus 1, one group of x plus 3, so my common denominator is going to be x negative 1, x positive 3. There's your common denominator, okay? We have two fractions up here, so we're going to write that common denominator twice because we have two fractions. There we go, and we're going to bring down this minus sign and put it here. Now, what do I have extra here that I don't have here? X positive 3. And then bring down your numerator, which is x. What do I have extra here that I don't have here? X negative 1. I have this and I have this. I have an extra x negative 1. So bring down your 4. And then x negative 1. Now let's continue. We're going to combine these two fractions, so there's my common denominator. Okay? And now I have x times x is x squared. X times 3 is 3x. Now be careful with your negative sign. This negative goes to everything up here. So negative 4, x negative 1. Or in other words, negative 4 times x. Negative 4x. Negative 4 times negative 1. Positive 4. So all of this is gone here. And now I'm ready to combine like terms. I end up with x squared, negative 4x, positive 7, because I have a positive 3 and a positive 4, all over my common denominator, which is this right here, and I hope that's the answer. They have a 4, don't they? Okay, let's see where I missed. Yes, I see my mistake, and I apologize, my young scholars. X times x is x squared. X times 3 is a positive 3x. Okay? So when you combine your like terms here, 4 is your constant term, so 4 stays a 4. And then 3x, negative x is negative 1x. So this term right here should be a negative 1x, or just negative x. And now we are looking really good. Alright, moving on to number 61. Okay, we have to find a common denominator because we're subtracting fractions. However, groups. Let's check your monomials first. I have a monomial here, none over here. So I have one x here and no x's over here. So my common denominator has an x. Now, how many groups of x plus 4? 1. How many groups here? 1. So I need one group. How many groups of x minus 4? 1. How many over here? None. So I need one group of x negative 4. Alright, so that is your common denominator. And we're going to write that twice because we have two fractions. So we're going to write it twice, put our fraction bars, bring down a negative sign. Now let's see, what do I have extra here that I don't have here? An x. And I'm bringing down an x. So x times x. What do I have extra here that I don't have here? X negative 4. Bring down your x negative 2. And there we go. I mean, let's do this. Let's combine these two fractions. We have a common denominator. So we'll put this here. X times x is x squared. Now there's a negative sign here, so be careful when you multiply x minus 2 times x negative 4. You'll get x squared, negative 6x, positive 8. However, this negative sign goes to everything, so your positive x squared becomes a negative x squared. Your negative 6x becomes a positive 6x. And your positive 8 becomes a negative 8. Now look up top here, you have x squared minus x squared, correct? X squared minus x squared. So I can get rid of those two x squareds very carefully. And so my entire numerator is now 6x negative 8, and that's not a negative sign there. And that should be, hopefully, our answer. Yes, it is. Alright, number 63. Okay, factor your denominators first so we can get a good common denominator. This can be factored into x negative 2, x positive 1. Because negative 2 times 1 is negative 2. When you combine them, you get a negative 1. So that's the factorization there. No other denominator can be factored. So let's see, I've got one group of x minus 2, no other groups up here, so I'll need one of those. I have one group of x plus 1 and one group here, so I need 1. And then I have a monomial right here at 2. And there's no 2's here and no 2's here, so I need 1 too. So there is my common denominator. We're going to put that twice, actually 3 times, because we have 3 fractions. So let's get a little more space here, I guess. Kind of like soccer, I need to create some space here. And there we go. Now between these two fractions here we have a negative sign. Between these two fractions a positive sign. Now what do I have extra here that I don't have here? A 2. And then bring down your numerator, x negative 5. What do I have extra here that I don't have here? Well, all of this. X negative 2, x positive 2. And then bring down your numerator, which is a 3. What do I have extra here that I don't have here? Oh, hold on a second, guys. Did I mess this up? I did, didn't I? I'm good at doing that, aren't I? Alright, let's start over again. Your common denominator would be 2. X negative 2, x positive 1. There we go. Now I hope that I got that this time, okay? There's my common denominator. So, we'll need it 3 times, obviously, for 3 fractions, and we don't need that, that's for sure. There we go. And there we go. Negative sign goes between these two fractions here, a positive sign goes here. What do you have extra here that you don't have here? A 2. Bring down your x negative 5. What do you have extra here that you don't have here? Well, all of this. So you have x negative 2, x positive 1. Bring down your 3. What do I have extra here that I don't have here? Well, I have a 2 and an x negative 2. And then I have 4x plus 1. Now guys, come on. It's kind of common sense. If you're going to do some multiplying, let's put the binomials beside each other. So I'm going to go ahead and put I've got a 2 and then x negative 2. Then I'll put the 4x positive 1 over here. It'll just make it easier later, okay? So there we go. I have this gut feeling I made a mistake somewhere, but I hope that I haven't. Okay, and now let's do our simplifying, okay? So I have, let's go ahead and put, I guess we can put our common denominator, and then put a nice, really long fraction bar. And here we go. 2x negative 10, right? 2 times x, 2 times negative 5. Now be careful here. I've got a negative sign. So I'm going to multiply my binomial times my binomial. I'll get x squared, negative x, negative 2. Okay? So I took this binomial times this binomial. Now I take my 3 and multiply it through, and I'll have 3x squared, negative 3x, negative 6. Okay? Took my 3 and multiplied it through, but this negative sign changes all of those signs. So positive 3x squared is negative 3x squared, negative 3x is positive 3x, and negative 6 is a positive 6. Okay? Now over here I have 2 times, okay, I would have 4x squared, negative 8, positive 1, that's negative 7x, negative 2. So if I multiply this binomial times this binomial, I'll get this right here. Now take your 2 and multiply it through. It's a positive sign here, so I'm not worried about my signs changing. 2 times 4, that's 8x squared. 2 times negative 7, negative 14x. 2 times negative 2, negative 4. Now let's do some combining, okay? I hope that I'm doing okay on the answer here. Okay, students, let's see my x squares. Let me get some space here. I'm going to go ahead and refill the answer and erase all of this. And I'm going to kind of go backwards and work up here now. So, simplifying my numerator, I've got a negative 3x squared and a positive 8. That's a 5x squared. So far, so good. My x is positive 2, positive 3, that's positive 5, minus 14. It's negative 9x. So far, so good. And a negative 10 and a positive 6 is a negative 4. Minus 4 more is a negative 8. So we did it. There we go. If you combine these three fractions, this is what you would get. Alright, number 65. Okay, well, we got our work cut out for us, don't we, guys? First of all, we need to factor this right here. This 4x squared plus 5x minus 6. So let's factor that down here, okay? And then we'll bring our work up top. There's nothing common I can pull out. 4 times negative 6 is negative 24. So I want a positive 8 and a negative 3. Because when you multiply those, you get negative 24. And when you combine those, you get a positive 5. So do you remember what to do? Bring down your 4x squared, bring down your negative 6. Right in the middle, put positive 8x, negative 3x. Pull out what's common in these first two terms. That's 4x. You're left with x positive 2. Pull out a negative 3 here, and you're left with x positive 2. So the factorization is x positive 2, 4x negative 3. So instead of having this right here, I'm going to have this instead right here. Now it's going to be hard to see, guys, but I'm going to try to squeeze that in here somewhere. Create a little more space. Make this a little smaller. And hopefully it'll fit in there, okay? But the best I can do. Yeah, there we go, okay? So, I've factored all of my denominators that can be factored. Don't worry about this negative 2 quite well. I'll tell you what. Yeah, let's go ahead and do this. Let's go ahead and put this over 1. And let's multiply this 2 through the parentheses. You know what? On second thought, I apologize, students. Let's not do that. Let's do this. If I had a fraction like 3/4, and then negative 2 like I do here, and then in here I had 1/2 plus 2/7, like this. You know what you would do? You would first add those two fractions, and then whatever, let's say you got 14, that'd be 7 plus 4, 11 14. So when you add these two fractions, you get 11 14s. you know what you would do? You would then take negative 2 times this. You would get negative 22 over 14. And then you would subtract those two fractions here. That's what we're going to do, okay? So let's start inside the parentheses and let's combine these two fractions. Let's combine this fraction with this fraction. Got it? So I've got x plus 2, one group of x plus 2, one group of x plus 2, one group of 4x minus 3, none over here. So my common denominator for these two fractions, I'm going to go ahead and write those two fractions right here. X over x positive 2 plus 5x over x plus 2, 4x minus 3. Alright, there we go. Now my common denominator, I have one group of x plus 2, one group of 4x plus 3, so my common denominator is going to be x positive 2, 4x negative 3, okay? And we're going to copy that. We have two fractions. And there we go. And there we go. Bring down your positive sign. What do I have extra here that I don't have here? 4x negative 3. Bring down your x. What do I have extra here that I don't have here? Nothing. So bring down your 5x. So you end up with 4x squared, right? X times 4x minus 3x plus 5x all over your common denominator, which goes right here. Now I can simplify a little further. I end up with 4x squared positive 2x all over my common denominator, which is this. Got it? So I'm going to erase all of this. Now listen carefully, students, please. I don't even care about these answers. I'm going to erase those in a second. But look, I took this fraction and this fraction, I combined them. So this goes inside your parentheses. Got it? This goes inside your parentheses. With what on the outside? A negative 2. You put the negative 2 over 1 if you want to. And then we have x positive 3. 4x negative 3. Do you see what I did, students? I took these two fractions here and I combined them and got this. Now next, you would not subtract these two fractions, you would multiply first. So you're taking negative 2 times this entire top. So you'd have x positive 3 over 4x negative 3. And then we have, and I do know what I'm doing, students. I'm trying to think of the easiest way to explain this, okay? So give me a second to do that. Okay, here's what I'm going to do, and I hope this doesn't confuse you. I'm going to leave the negative sign right here between the two fractions, and I'm going to take a 2 and multiply it through. So you get 8x squared positive 4x. Mr. Arrow, those signs should have changed because of a negative 2. Well, you're right, but think about it for a second. Think about this. I'm going to take this negative later and put it to the whole top, so those signs will change later. I just felt like it was better to bring the negative sign down and just multiply through by a positive 2. And these signs will change later, okay? So I've taken my 2, I've multiplied it through, I brought down my negative sign. So now, all that I have left to do is combine these two fractions. Now, I will grant you this. This has been a really tough problem, or at least a long problem, but we're almost done. Now what's going to happen probably is you probably made a mistake way back at the beginning. But we'll see. Okay, what's a common denominator? Well, look, guys, I have one group of 4x minus 3 at the most. In each group, I have one group of x plus 2. So I think my common denominator stays the same. So there's my common denominator, and there's my common denominator. It's the same. So there we go. There we go. Bring down your minus sign. What do I have extra here I don't have here? Well, x positive 2. And bring down your x positive 3. Okay, what do I have extra here I don't have here? Nothing. So bring down your 8x squared and your positive 4x. Now if you multiply these two groups together, you will get x squared positive 5x positive 6. Okay? So now let's combine these two fractions. Here's your common denominator. We'll put that here. And we'll put a really long fraction bar. Like this. And now let's combine. We have x squared positive 5x positive 6. This negative sign changes all those signs. Negative 8x squared negative 4x. And now we're ready to combine like terms. And we'll probably have to do the whole problem over again. I hope not, but we'll see. We have a negative 7x squared. That's good. X says we have a positive x. That's good. And we have a positive 6. Well, we actually got it right. So if you take x squared minus 8, that's negative 7x squared. 5x minus 4x is 1x. And then positive 6 is this. All over your common denominator, which is this. Okay? Wow, that was a long problem. So let's go over it again. You first add these two fractions together in the parentheses so that you have one fraction. Then take that one fraction times 2. And that gives you a fraction here and a fraction here. And then combine those two fractions. Okay, one more problem. And then this break, this video will be done. Part 1 will be finished, okay? Okay, remember when you have a complex fraction, your goal is to get one fraction up here and one fraction down here. That's your goal, okay? That's your goal. So here we go. Let's work with my top two fractions. Forget this right now. Let's work with my top two fractions, okay? So x negative 3 over x plus x over x positive 4. Now your common denominator, you have a monomial here, 1x. No x's over here. You have one group of x plus 4 and none over here. So there's your common denominator, okay? For both fractions. So let's write that twice because we have two fractions. Bring down your positive sign. What do I have extra here I don't have here? X positive 4. Bring down your x negative 3. What do I have extra here I don't have here? An x, and bring down an x squared. Now I want to give you some advice. No, I was going to say not to multiply this through, but I would actually. So x minus 3 times x plus 4 is x squared. Positive x, negative 12. Alright, so we end up with, when we combine these two fractions, there's my common denominator. And I have x squared plus x squared, 2x squared. Positive x, negative 12. Alright, so when I combined these two fractions here, I got this right here up top. Alright, now let's work our way down to these two fractions. These two fractions here, let's combine those two fractions, okay? And let's see what we get. So I have 3 over x plus 4. Positive x over 5. Now, you have one group of 5, no 5's over here. You have one group of x plus 4, none over here. So there's your common denominator, alright? So there we go. And there, and there. Write your common denominator twice because we have two fractions we're combining. What do I have extra here I don't have here? 5. And bring down your 3. What do I have extra here I don't have here? X plus 4. Bring down your x. So let's combine our two fractions. First of all, 3 times 5 is 15. Over here, x times x is x squared. X times 4 is 4x. So I end up with x squared, positive 4x, positive 15. So that's going to be, put a really big fraction bar here, that's going to be in the bottom, like this, alright? So there we go. So we're now going to take our top fraction, and we're going to multiply it by the bottom fraction because we're going to flip the second fraction. We're going to put 5x plus 4 up top, and we're going to put x squared, positive 4x, positive 15 in the denominator. And now let's see what we can cancel. This will cancel with this. And please don't start canceling x squared with x squared and x with x. This is a trinomial and a trinomial. If you're gonna factor, it has to be, if not factor, if you're gonna reduce or cancel, you have to have a exact trinomial and exact trinomial, and you cross the whole thing off, okay? And we don't have that. Alright, so please do not do any canceling there. We end up with 5 5 times this group here. So 5 times 2x squared positive x negative 12 over x times this group here. So x times x squared positive 4x positive 15. Now I'm okay with that answer. If you want to go a little further, that's fine. You could put 10x squared positive 5x negative 16 all over x cubed plus 4x squared plus 15x. And believe it or not, I just checked the answer in the back of the book. We're actually right, so that's good. So this answer is fine. This answer is fine. The answer they had was this one right here. I'm fine with either one, okay? Alright guys, I hope that I hope this video's been a help to you. If you have any questions, don't hesitate to call or